Camera's rolling.
Ben, can you tell us when you came here the first time, what was it like?
Yeah, so I showed up at the site for the first time in the summer of 2011, in August, and I'd heard a lot about the site, but it's striking. You can see the site a few miles off, so as we approached in the helicopter, it looked like a construction site out in the middle of the tundra, miles away from any road or human settlement. And just hearing the churning of the soil and seeing this strange exposed ice face, it was like a landscape from a different planet.
Did you feel like you'd gone, every time I ask you a question, you'll need to paraphrase the question and the answer. Yeah? Did you feel like you'd just gone through a time warp when you came here?
There definitely was a feel of having gone through a kind of time warp where you're no longer in the 21st century, but you're back in the past with the bison and mammoth that are melting out of this hill slope.
What have people found in this hill slope?
One of the most surprising things that we found as far as the organic matter coming out of this hill slope is that it's much more bioavailable, meaning it's yummier for the microbes that are decomposing it than carbon or organic matter near the surface today. So that has climate implications because that means that this organic matter is processed quicker. It's returned to the atmosphere as carbon dioxide and methane and can feed back on climate that way.
So does this mean this is an accelerator?
Sites like this where the permafrost is releasing organic matter act as accelerators. They speed up the process of human-caused climate change. And in fact, a recent study showed that the contribution of of organic matter being released from the permafrost region might amplify human impacts by up to 30%. So we put out a certain amount of carbon each year, around 10 petagrams, 10 gigatons of carbon each year. The permafrost system may respond by contributing up to 3 gigatons of carbon. So it's a large amplification of what we're doing. It feeds back onto our impacts.
That's excellent. Can you give that to me again in a very short précis for someone who knows nothing about it? Because I think what you're trying to say is this is amplifying the speed at which we're approaching a tipping point in our climate change. I think you're talking about this acts as an accelerator. If you could maybe just phrase that again.
So sites like this, where the permafrost is collapsing and releasing organic matter, accelerate human-caused climate change. It feeds back and speeds up the process, speeds up our approach to a point where there's a tipping point in the climate system.
Is methane really a bit of a wild card in the climate story?
The release of organic matter from the permafrost region is something of a wild card. There is a lot of uncertainty. We don't know how fast it's going to be released, and we don't know how much of it's going to be released. Particularly the release of methane has the possibility of very quickly changing the way that the climate system works up here in the Arctic and also around the globe. It's predicted that the Arctic will become the biggest source of methane in the next few decades of global sources of methane.
I guess sites like this, it's so hidden, we don't really see it, do we? So it's hard for people who are living in America or England or Europe to really get a sense of what's happening up here.
You don't see places like this just driving down the highway, and so it's easy not to think about them or to assume that they're unimportant. But just because it's remote and nobody lives here doesn't mean that it can't feed back and affect the global climate. And in fact, that's what we're finding, is that release from these remote sites may be very important to the story of climate change over the next few decades and centuries.
What do sites like this tell us from what's happened to abrupt climate change in the past?
Sites like this are...
Sorry, Ben, one more time.
Sites like this are good examples of what has happened in the past. So we can learn lots of clues about what happened at the end of the last ice age, which was also a time of rapid climate change. What we learned from this site is that the whole landscape up here in the Arctic subsided. It fell down and organic matter was released to the atmosphere. That was one of the main mechanisms that brought us out of the last ice age. This also happened about 55 million years ago, where the temperatures were increased by 5 degrees Celsius, which may not sound like much, but that's the difference between an ice age and a warm period.
And so if predictions for our climate system to heat up in 100 years, 3 to 4 degrees, what does that mean to you as a scientist?
So it's predicted that global temperatures may increase by 2 to 5 degrees by the end of the century, but change is occurring much faster here in the Arctic. It's called polar amplification, where loss of sea ice and transfer of heat from the equator up to the poles makes everything accelerated up here. It's happening much faster. So this would be a different landscape in 100 years if we increase the temperature even by 2 or 3 degrees.
And can you make a comment? I mean, obviously, it only takes 4 or 5 degrees to tip a climate system, and that usually happens over thousands of years. The fact that it's going to happen over 100 years, could you give us a sense of a perspective from that? How dramatic is that for you as a scientist to imagine?
So 55 million years ago, the climate warmed 5 degrees over several thousand years. That changed Antarctica from a place that was covered in vegetation, covered in tundra, to a place that was covered in ice. Huge change. It's important to realize that the scale and rate of change that we're talking about now is several degrees, 2 to 5 degrees in just 100 years. So this is much faster than has happened in the last 50 million years. We're talking about unprecedented climate change and a very rapid, abrupt response from this ecosystem.
That was absolutely so brilliant. Just tell me, 2 things. Did anybody hear the glitch on the sound then? Was that a problem or is it just my mic?
It's yours.
Okay, great. Ben, what sort of clues are you looking for when you come to a site like this?
It's really exciting as a scientist to come to a site like this because we're climate and ecosystem detectives. We're looking for clues. We want to know how the climate was in the past and how it may change in the future. And so at a site like this, we can look back and see how quickly did carbon get into the soil and how quickly can that organic matter be released out of the soil. And what we're learning is it takes a long time. It takes thousands of years to get this organic matter built up in the soil. But it can be released very quickly, on the order of years to decades.
And what are you going to
Can we get that one more time, sorry? It's a great answer. One more time.
What was the...
Sorry, Ben, one second.
No worries. Yeah, what was the question
What
again?
sort of clues are you looking for here in the system? I love that climate detector. That was great.
Sorry, mate, hang on.